let's jump into the evolution of test automation. Like I said in the beginning, I worked for this company that invented the UML, right? And at this time, we were actually showing capture replay tools. And when you look at the evolution of test automation, capture replay tools are really nice. We demoed them. They are like magic. You know, you should see the customer face when they see like how magically this works and everything. The only problem with the capture replay tools is they don't work in the long run. So the capture replay approach itself doesn't work. And what you see with any customer who bought one of these tools is they will get into scripting. Okay? There's no way that you see experienced test automation customers using the recorder. Maybe just to inspect some of the controls to see what technology lies behind that. But the rest is done scripting. And this leads me to more or less this part. So with scripting, the first thing you do is you realize that the recording is too long, unstructured. You need to have modules. You need to structure this a little bit. Now, all of a sudden, you need to have interfaces where you pass parameters between the scripts. You need to separate some information. You find out that some information is changing very often. You kind of like take this in a module and put this somewhere aside so you can control it and everything. And all these steps will lead you in the direction of creating a test automation framework. Can be data-driven, can be keyword-driven, but somehow you move in this direction. And we've seen customers do this. It can work, but it becomes expensive. Because now you have 2 people in your team that are actually only working on that framework. They don't do anything else. They maintain the framework. You have to implement this maybe for every technology that you test. So you want to test 5, 10, maybe more end-to-end tests. You have to implement this. And this is really where this becomes too expensive. And this is when actually Tricentis got into the market with this model-based test automation approach. The basic idea is the strict separation between technology and the business logic. Really strict, okay? In Tosca, you see the test cases. They are almost plain English. Anyone can read them. They look like manual test cases. And they become automated test cases the moment you connect them with the so-called modules. And this is where all the technical information is encapsulated in this. You can still do coding stuff and everything with Tosca. Okay? When you get more advanced, there is a custom execution task that you can write. You can do all kinds of funky stuff with that tool, okay? But in first place, it represents itself very clean and very separated. You have the business logic and you have the technical information. That's all you need. And I think the big advantage of this is that we have case studies, and we can show you those case studies. Customers actually achieved up to 90% automation rates, okay? In this range, and now you understand what I said my theory is behind this. When I showed you the chart with only 20 to 30% test automation, it's the reason because you're somewhere in between here and here. Maybe you did some framework, but this is typically where you end up with 10, 20% automation rates. So the model-based automation, I will show you a little bit more about this. We were sitting in our office in Vienna, enjoying the gorgeous view over the lovely city of Vienna. I'm just doing some advertising here for Vienna. And we were thinking, like, could we create this capture replay approach and create model-based tests out of it? Basically, the idea is, can we accelerate the creation of the test cases? We knew that capture replay has a bad reputation. So we kind of stay away from calling it capture replay. But can we accelerate the test case creation by adding a recorder? And you will see this in a little bit. We did it, actually. We released with this version, we released the recorder, which is now for the cross-browser or for the HTML testing. Okay, so let's take a look at this. This is really what I just mentioned is you have a system under test. It doesn't matter if it's UI-based or API-based. And from that system, you abstract the models. Okay? And I literally mean it doesn't matter if it's UI or API-based. You create your models, and you have your test cases, which you hopefully created with test case design. And once you want to run those as automated test cases, you take the models and just connect them with your test case. And whenever you run this, the model is responsible to actually steer and interact with the application. If you have to update something, if something changes, you don't have to go here in one of your 2,000 test cases, okay? You update it here in one single place. If you need to enhance some controls, you do it here. It will automatically be available here, and it will be used here. So that's basically the idea behind this. Now let me show you this. So this would be the application that you want to test here, and this would be your Tosca test script. What would happen is when you interact with the application, it will automatically record that interaction and put it into a model-based test automation format, okay? The format is very simple. You have a step here, you have a value, and you have an action mode, typically. In this case, it's a text field. I entered Porsche, and it was an input action. That's it. And you see it extracted the technical information and stored it as a model here. Okay? We can play this game, and we just like interact. You see the different steps. Whatever I enter goes in here. And then I click next. So when you see enter meaning again, we create another model. So that's the modules are structured. We don't create one monolithic module, and we create them non-redundant. That means if I would click on the same control here again, it would not create another model. It would reuse the existing model, and it would reuse the existing control. Only if there's something new that has not been added to the model before, it will add it to the model. Okay? So this is sort of what this would look like. This is what a Tosca test case looks like here. Okay? How many of you are familiar with Tosca? Who is? Okay, so the majority. This test case is exactly the same test case as you would have created if you used the XCAN, for example, and pulled together your modules and your test case. Same thing. And that's available as a recorder now. So this was one of the main features that we just released in 9.0. Basically, that's the salesy part of the slide. But the important part is you can create test case, model-based test case, including custom controls. Okay? This is really important. The recorder is based on the XCAN technology. It has implications for the future. As you, when we talk about the roadmap, I will speak about this. We bring the main engines onto the new technology. We call it Engine 3.0. And every new engine will come with the recorder. So this time we released the SAP engine. And in 9.1, we will have the recorder on the SAP engine as well. Okay? It's non-redundant, so you don't run into the mess with the capture replay. And it will enable exactly your manual testers to actually create test cases from scratch. Anyone can do this. I mean, you can just start it, click on it, and at the end you get a test case. Okay, I wanted to show you this. This is a test case from our famous insurance calculator, right? You would see this here. And here, for illustration purpose, some of the modules. And now I wanted to show you, this is what it looks like when you use a capture replay tool that is script-based to simply address a field element in the table. Okay? This is actually a Selenium script. I'm not saying Selenium is a bad tool. Actually, we embrace Selenium, and you can run Selenium tests with Tosca. But I just wanted to give you a comparison of the level of complexity. This is the same test case that you see here on the Tosca slide. And it keeps running for a while, trust me. I've seen this slide multiple times. I could also use any other script that gets generated. This is the reason why we believe that the future for the manual testers lies in this recording technology. Okay? For Selenium, there's some additional things that you would have to think about. It's like synchronization behavior. You have to take care of this. That means that you have to implement probably some frameworks. You will have to deal with the recovery handling. I mean, everyone who runs a regression overnight knows that things happen. and you need to be able to deal with unexpected behavior. Data-driven frameworks, you would have to add on top of this, and keyword-driven frameworks if you want to go that far, with the Selenium scripts, for example. So this is kind of like the difference. Now, we added some more to this release, okay? And what we did now is we call it flow, because I think it's the natural flow. First, you record your test case. Now you have your test case here. And you take the test case and you drag it into your test case design. Okay? You take your blue test case and drop it into the red section. What will happen is it will create a test sheet for you. Okay? It will create a test sheet and will take all the fields that you have used here and will create attributes out of them. And from the values that you have used, or even like the instances that you have used in a list box, it will create instances in here. Okay? So with one drag and drop, you just created a test sheet and your straight through test case. Now you can actually start doing test case design, add some values or do a linear expansion with that, and you will get your test cases. Okay? On top of that, okay, with the drag and drop, I get a template instead of my test case. I don't know how many of you are familiar now. We're getting really Toskerish. You get a template, and the hard-coded values that you used to have here are replaced with the values from the test sheet. It's one drag and drop, okay, that you have to do to get this. And then you take your template folder and you drag it onto the execution list, and you have a ready-to-go execution list for your test case. It literally takes you 5 minutes to create a test case design, and drag it into the execution list. Okay. So the idea is with the DevOps speed that you can create test cases in minutes. You can use test case design, and you can create data-driven tests with a simple drag and drop action. And you can create your ready-to-go execution lists, more or less, directly out of that. So basically, that's the idea. Those are some of the features. I'd like to show you this actually live. Basically, the idea is that what you see here is now, this is the recording panel down here. You can either pause or you can stop your recording. In this case, I want to do a very simple recording here. It's going to go to this application. Let me see. We take the automobile as a test case. It goes on to this one. So this is the one that you have seen. You know, I'm a big BMW fan. It's the engine performance. It's like 300 horsepower here. What else can we do? We can do the list price. The list price is like, say 50,000. And what else do we need? The mileage, right? Mileage, 10,000 miles. Okay, so at this point we can do, now let me go a little further. And now we go and go to the next page. We have to enter this. Okay. I'm just going through the mandatory fields, so that it allows me to continue. Nice. Okay, that's my date of birth. You can compliment me that I look much younger. Thank you. What else is mandatory? I think that's it, right? Okay, then let's go. Click the next. Okay, so this is where you get the insurance. We can do here is we can do a verification real quick, and we do a verification on this one. Okay, that should do it. And then we say next, and that's it. Okay, that's the insurance quote. And now we're at the recording, and I say thank you. Okay, so let's take a look at this. So what you see here is the test case that I just recorded. Exactly the interactions, everything I did with the application. You see the verification points that I added here for the insurance amount and for the premium, how often it's paid, and more or less this is the same way how you would create it yourself, okay? Maybe as a background here, I don't know, you see these are the modules that were created during the recording, okay? So you see all these different modules here. If I had existing modules before that in this repository, it would have used those instead of this, because this is like the first recording I did. It created all the modules here, okay? So like I said before, this is the recording. I take the test case now, and I go into the test case design section. You can see it's empty, right? I'm taking it up here, and I'm dragging and dropping it into this section. Now let's open it up on the test case, and let's go up here. Okay, so what you see now is the simple drag and drop that I did from the test case into the test case design created all these attributes. And it assumed that this is the straight through. So you see the dark red values here. I don't know if I clicked on the fuel here. Probably not, I didn't. So you can see the instances that we have in here. What you can do now is you can either add your instances yourself, right? You can enter some values in here, or you go up here and say like, okay, generate instances, and here are all the different methods that I mentioned that you can use. You can use all combinations, linear expansions with relations, and so forth. So let's do this. Now in this simple case, we actually only created the straight through without the attributes. I didn't click on a real field. What I wanted to show you then is, if you go back to the recording and you take a look at this recording test case now, you see that the values have been replaced. So it was converted into a template. And you see that in here, you see the values have been replaced and linked to the test sheet. So with this one drag and drop, I actually created a data-driven test case here. Okay? I can take this instances here. In this case, it's only one test case. And go down to the execution and drag it onto the execution lists. And immediately you have your test case here that you can execute. Okay? So within minutes, actually, you can click, create, test case design, and your instances and run that test case through distributed execution, for example, if you have it installed. I don't have it on my machine, but that's the way you would suggest to create those test cases. And compared to what you're used to do with your Xcan, that is a much faster way, right? Instead of you're creating your modules. And the good news is that we will do this for every new engine that we will develop. So every engine that will be released will have its recorder. And we're working with released SAP engine. We're working on a Java engine, a .NET engine, UIA, Win32, PuTTY, TextStream, PDF, and all these engines that you need to actually do your end-to-end testing. So that's the demo part. The next, after the demo, what I wanted to show you is the end-to-end testing approach, right? In the end-to-end testing, what you would do now in your previous, how you create your test cases, you would have your modules and your test cases for one application. But there's always a link to other systems. As soon as you get it into your system integration testing, you will interact with other applications, right? You will have backend services, you will have mobile interfaces and everything. And this is where Tosca is actually really strong, because we support over 30 different environments with this. Okay, so you can test anything from HTML over legacy technologies, Gupta, SAP, whatever you need to test, more or less you can do it with Tosca. And I think one of the key strengths in this automation model is that we have a specific layer where you can actually write custom controls and extensions. Okay? Why is this important? Because I haven't seen many projects where the customer would do serious automation where you don't run into some custom controls. Okay? It is important that you have the possibility here actually to write custom controls in order to get up to 80-90% test automation. So we support this. Here's an example. When we talk and we say like API testing needs to explode, right? API testing can be quite technical for many testers. The question is, UI testing, you understand that, but web services, that looks complicated and everything. The truth is, with Tosca, you can actually make it look and feel like it's almost like a UI test. There's no big difference. You see only that the type of parameters is different, but the principles are the same. You have the same values here like you would use up here in a UI test case. You could also use your test case design. You could also do your test data management and everything connected to that. So even the manual testers can do this. That's really the core message of this. This is the testing pyramid, and I don't know how many of you are familiar with this. At the moment, the classic test pyramid looks something like this. In terms of effort that we spend, it gets bigger and bigger the higher we get. At the moment, the focus or the most effort is really end-to-end testing, UI-based testing, right? System integration tests here, and here's the unit test. With the agile movement and the DevOps, this has to turn around. And that is the shift left, actually. So when you look at this, the way it needs to look is something like this. Here, early on, you have to do the unit tests, and then you have to do the integration tests. A lot of API testing, system integration tests, and less so on this end. That's basically the idea. And when you look at this, when we talk with customers, this one is actually, I think, well understood by development or by engineers. It only requires the right level of discipline. Okay? I mean, there's nothing you can do or we can do about this. The organization needs to be disciplined to do this. What we can do here is actually in this level here, we can provide service virtualization. And why is this so important? I mean, there's reports out there that say there's like an average of 33 systems, backend systems in place that you need to use for your integration testing. The tester, I think, has only access to about 16 of them. Some services are not available. So this is where you actually need the virtualization part of this. Okay, and when you look at the situation here, so here would be the tester, manual tester, or maybe it's a test tool like Tosca. You would run your tests and you perform those tests on the system under test. In that system, you use some backend services. System B and system C, it's illustrated, right? You send a request, system does something, gives you a response. Same thing here. Now, the problem is when those systems are not available, you're stuck. There's nothing you can do. This could be either a system that they are currently writing. Okay, they're developing that system as well. There's other systems where the test data is not consistent. You don't have production data there, or you don't have data in there. The service is broken. They have to fix it, so it's not reliable. Or it's a third-party service that you don't have. Right? Any online credit check or something, you would have to pay for each of the requests. In no testing environment, you will have these services available. And this is where you use OSV. It's called orchestrated service virtualization, actually. It goes a step further than what service virtualization does. Service virtualization is simulating input-output behavior. Okay? I send you a request A, you give me the response for that request. It's very simple. It's typically like a table, more or less. Orchestrated service virtualization goes further because it can act, like here are the points, what the difference is, but it can act stateful. There's a difference when I send the same request twice to a system. The first time I get response A, the second time I get response B. For whatever reason, okay? The state of that record may have changed, and now I get a different response. You can't do this with the usual service virtualization tool. You have to do some coding there. OSV can act both as a server and as a client. Okay? So with OSV, I could actually simulate system B in here. I could be the server from this side and simulate the input-output behavior for this, but I could also send those requests to the real system here. So if I just want to replace system B, good luck if you use a plain service virtualization tool with that. So you see that this is really I think the future of service virtualization will go in this direction with the orchestrated. We originally created that tool in Europe for when the European Central Bank actually introduced a new standard in the SWIFT definition. It's an ISO 20000 something, whatever, complex. They had the XML definitions of that process workflow before they had the systems in place. And the banks had to prepare for that before any live services or systems were there. And the only way how they could do this, if they don't want to do it manually, was to actually use something like the orchestrated service virtualization. It was the only tool in the market that was able to orchestrate messages among different systems and verify them. That's how the system came into life. To give you some stats here, when you look at where defects are typically found, you will see that in unit testing you find around 20% of the defects, integration 30%, then it goes down to 25%, and then between 25 and 20, and so forth. When you use OSV as a virtualization in here, you can actually find more defects earlier. And that is exactly what shift left means. You find more defects earlier, you test earlier. And I'm adding the numbers on the bottom here. The cost per defect, if you set them to 1 in unit testing and then integration twice, triple, 5 times, 20 times, with a shift like this, what you see here in this chart, you can reduce the cost of those defects by 38%. By 38%, and that actually does not include the cost that you would have for the systems itself. Just imagine you have an environment with 30 services that you need to host, that you need to use, maintain, and everything. Those costs will be on top of this. But just with looking at those defect costs, you can actually shift it. Reduce it by 38%. Okay, now we get into the integration part of the DevOps story. There's 3 different integrations that I would like to mention here. One is distributed execution. And more or less what distributed execution does is, I think, the only phrase that really makes sense here is divide and conquer. You have a regression suite of 5,000 test cases. You want to run it overnight. You want to use every resource that you have in your test lab. Okay? You can run and distribute your test cases on as many machines as you want. It also is configuration-based, which means that if you run an SAP test, you want that to run on a machine where you have an SAP client, not on a different machine. So this agents here, they all have configurations. And they tell you that it's a Windows 7, Internet Explorer, and SAP, and whatever you can also custom define those configurations. And they will be waiting to get orders from the execution server. Okay? Of course, you want to monitor this and see this and get the results reported. That is more or less the easiest way how you gain performance or speed in your environment. The most common approach that we see in customers is continuous integration. Continuous integration, you have different tools out there, Jenkins, Bamboo, TeamCity, Electric Cloud, Atomic. Those are the most common tools out there. What they do is they orchestrate your entire DevOps chain. Okay? So the coder writes some code, checks it into the repository. The CI tool will trigger, let's say, unit tests. The first thing is you have the unit tests running. Once they are passed, it will trigger a smoke test, for example. Okay, you can also combine this with a deployment tool that will actually deploy the software into your testing environment. Then you run your smoke test. Once the smoke tests are passed, you deploy it in your staging environment, and you run the regression tests. Those kind of activities are typically controlled by a CI tool. Tosca is perfectly plugged into that infrastructure. So you can use Jenkins and you can run your Tosca test cases. We at Tricentis, for example, we run daily builds. So we release once a day, and we test them overnight. We run overnight regressions every single day. It doesn't mean that we are releasing like every other day our software to customers. We release it actually every quarter. And the third integration, which is a fairly recent integration that we did with a French partner company actually in the area of performance testing. And that was interesting because I spent some time in performance testing, and I thought about it like, whoa, you want to run your functional tests with performance tests and everything? And then we talked about it and came up with this integration here. It's called Neotest or Neoload. It could be any performance testing tool, to be honest. What we can do is, while you're doing your performance test, you can actually choose one of your test cases from your functional test case portfolio in Tosca, and you run it in parallel. It comes with specific timers, so it will time every user interaction. And not only will it tell you if it's passed or failed, but it will also give you timer progress for each of the steps that you executed. I mean, the advantage really is that you can combine those two tests, obviously, but you can also bring the business risk approach to performance testing. Whenever I see performance testers, they're typically talking about technical details, like how many requests can you handle, is there memory leak, how many open session objects do I have, and so forth. They are not always that concerned whether the business case is really working the way it's supposed to be. With this, you can actually run your most important functional test cases, and you can guarantee that even under performance, you can still run your most important transactions. With some performance degradation probably, but that's it. So this is something we've done. I think that's an interesting way. And the performance testing companies actually are also pushing more into this DevOps cycle. So they want to get the development teams to run more or less performance tests with every sprint, which I think is an interesting approach, because performance testing typically is done at the very end of the project, when everything is finished, documentation is finished. They just didn't print the papers yet. Then they come up with this idea, oh, we need to do a performance test. This is how it's done, I think, in the last 10 years. Now, if they push more into the agile, I think they will do performance tests also in a sprint cycle. You will run your performance tests, you will use your functional tests with that, and you will combine and build up your regression tests over time. So basically, that's the idea. Yeah, I promised you a real-world example. Let's start here. This is really Tricentis in action, I would say. It's the most typical situation that you will see. We get to a customer, they have 2,000 test cases. Risk coverage at this time, we don't even know, okay? They do manual testing, the whole testing takes them 8 weeks. It takes them 4 days to even run a smoke test, okay? This is how complicated this is and how it works in the manual testing organization. So when we came, the first thing we did is we did actually the optimize, which means we analyzed the test case portfolio. What we do is we typically do like 1 day or 2 day workshops with the line of business, and we prioritize the requirements and everything. When you see here, we transformed the portfolio from 2,000 into 600 test cases. And I'm always saying, like, we transform, because please don't think that we go and we take those 2,000 test cases and we just like delete them. These are transformed test cases. They're different, okay? With those 600 test cases, we managed to get the business risk up to 85%. And this is the reason why I think it's absolutely paradox. If I ask you how much business risk do you cover and you tell me 2,000 test cases, it has nothing to do with the business risk in terms of how many test cases you have. So the whole execution time was still 5 weeks. A lot of people that see that slide say, like, whoa, how is that possible? You reduced the test cases almost to a quarter, and then the execution time only went down by 3 weeks. What went wrong? Any ideas? So, I mean, the test cases have changed. They might be more complex, I understand. What else is missing? What is missing in this picture? No ideas?
Multiple iterations.
Multiple iteration? No, was not the problem in this case. The one thing that nobody thinks about actually is test data. Test data management in manual testing takes up to 60% of your time to provide the right test data. So we implemented test data management here, provided them with synthetic test data, and it took the whole execution down to 2 weeks. And now we are roughly in the same proportion again, right? What we did then is we started to do the obvious, the automation, and then we implemented regression testing, which was able to be executed in 2 days, smoke test in 1 hour, and we got an automation level of 87%. Okay, smoke tests are supposed to be around 1 hour. They shouldn't be too long. We just want to get a solid understanding what it is. Smoke tests, regression tests, 2 days. I think that change from 8 weeks down to 2 days is pretty awesome at this point, right? The goal was actually to get a daily build. Okay, so we were still not there. And that's when we implemented the distributed execution and the continuous integration. We got to a level where we could run the regression tests below 3 hours. And this is because you run them distributed, and there's a new word in there. We kind of invented that. We call it continuous regression. It's a little bit of magic, I have to admit. Basically, the idea is that you only run the regression that you have to run. So you change a part of your application, you run, let's say, the smoke tests across the board of your application, and you go deep on those areas where you have to. Like you run the regression tests on that part of the application where you did most of the changes. That's basically the idea here. So this is, I think, a huge success story. Okay, and we've multiple stories. I don't know, Thomas, if you have shared at some point more of those stories. You can also find it on the website, actually. We have other success stories that more or less look almost the same. Okay, so that's typically, like to see. And that's more or less the end of my presentation now. We are at the DevOps, and we think that continuous testing is the most important part of this whole chain. Okay, we would actually like to rename it into test ops, because we think that testing is really important, and I hope you agree with us on this, because without testing you don't know which quality you deploy. Okay, and that's why we believe that DevOps is all about continuous testing. Okay, and with that, I'm at the end of my presentation now.
By the way, the exploratory test functionality that you have seen today has been developed by my QE over there. So made in New Zealand.
Made in New Zealand.
It's true, isn't it true?
Yeah, it is.
There are some other aspects that people heard about, for example, image recognition, the engine developed by QE is much more than that. He's developing more tricentennial as part of our agile software development.
Okay, so every year we have our annual conference. It's called the Accelerate Conference in Vienna, actually. And this year we had, I think it was 360 or 370 attendees. The event is growing. We actually had to close our registration at some point, which was amazing for marketing to have such a success. Next year they need to find a bigger venue, I guess. We had customers from all over the world attending. If you're interested, we can always schedule a one-on-one like roadmap session. And I can take you through some of the details, and we can talk about specifics in the backlog. That would be too much for this session today now. And that's it. That's the roadmap.